Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, you will go through the second part of making a configuration file for reducing two-dimensional images to one-dimensional scattering profiles in RAW. This covers how to make a mask for an image. So, when you're reducing data, it's important to mask out unwanted portions of the image. This could include the beam stop, bad detector pixels, and gaps between modules in the detector, for example. This tutorial assumes that you've done the previous configuration tutorial and you've already done the centering and calibration. Additionally, it uses the tutorial data from the RAW website. So the first thing we're going to do is we're going to show this image for water here. I like to use a relatively low scattering kind of flat image so that we know that we're seeing kind of uniform scattering across the image. Find if you have something very bright, you can get a little bleed over on the beam stop pixels here. And if you use something with too little scattering, it can be very hard to see where the edges of the beam stop are. Because we'd previously set a log scale for the calibration image, this loaded up as a log scale. I'm going to set it back as a linear scale. I'm also going to set the upper limit here to 30. I'm going to go ahead and lock that in case I decide to change the image. And I'm going to click OK. So first thing I'm going to do is I'm going to set the beam stop mask. I'm going to zoom in near the beam stop. And then I'm going to drag the image so I can see beyond the edge of the image. Now we're ready to open the masking panel. So I'm going to go to Tools, Masking. If you had a mask currently set, you would click Show, and then that would allow you to modify that mask. Since we don't have a mask currently set, I'm just going to start drawing the mask now. The first thing I'm going to do is I'm going to draw a circle mask over the circular part of the beam stop. So I clicked on the circle, I'm going to click somewhere near the center of the beam stop, and then I'm just going to drag my mouse out, and you can see the circle outline gets larger as I move my mouse. I'm going to click again. That actually makes the mask at that radius, and you can see it here in red. So you'll notice it's not lined up perfectly with the beam stop. I just zoomed in using the scroll wheel. I can click and drag it to align it a little bit better. And then I'm going to click away. We could maybe try to adjust this a little bit to make it pixel perfect, but we're not going to lose very much information this way, and there's no reason to push too hard on your masking, because then you might accidentally include pixels that you shouldn't. In fact, I might just drag this back a little bit like that. And I think actually it wants to be maybe 1 pixel bigger, so I'm going to right-click, select Resize, and drag it out. So this, I'm happier with this. We're not so tight on the edge of the beam stop that I have to worry that maybe I've missed a pixel somewhere, even though we are going to sacrifice just a tiny bit of the low Q. So now I'm going to zoom back out a little bit so I can see over the edge of the image again. And now I'm going to draw a mask over the beam stop stalk. So to do that, I'm going to use the polygon tool. I'm going to click on that. And then each time I click, it's going to add a vertex to the polygon. So I'm going to click once here. I'm going to click out past the edge of the beam stop. You can see the line as I'm drawing it. I'm going to click again out here. I'm going to go down, click, come in, draw the beam stop back to here, and then I'm going to left click to finalize the polygon. So you can see now I have this polygon mask covering the beam stop stalk. Again, I didn't want to push too close to the edges of the stalk. We're not really losing a lot of information here, and I don't want to risk having pixels that should be masked that aren't masked. So now I'm going to zoom back out to the full extent of the image. The next thing we're going to do is we're going to mask all the bad pixels. On a Pilatus detector, bad pixels have values of -2. So in this automatic masking section, mask pixels equal to -2, I'm going to click Create, and that's going to create a bunch of small masks all over the image that mask bad pixels. They're hard to see on this scale, but if I zoom in, for example here, you can see there's a bad pixel, value -2, that now has a little red square mask over it. I'm going to zoom back out. I also want to mask the detector gaps. This can again be done automatically if you give it the detector type, which is 1M, Pilatus 1M, and then click Create. And you can see that's automatically, oh, sorry, I zoomed there. That's automatically created a mask over all the detector gaps. Once we're happy with the mask, which I am in this case, you then want to click Set, and that will set the beam stop mask. Click OK, and then you can click OK to exit the masking panel. I want to open the masking panel back up just to emphasize one point. There are these save to file and load from file. Don't be confused by these. These allow you to save the mask to a separate file, so you could load it into, say, another program, but they're not what you want to use if you want to save the mask for use in RAW. For that, you just want to click Set. If we wanted to modify the mask that we just made, I would open this panel, I would click Show, you can see the mask there, and then I could modify any of the individual elements. If you want to remove an element, you can click on it and then press the Delete key on your keyboard. If you want to resize it, once you've selected it, you can right-click and click Resize, and there's a few other options as well. With that, that's the end of the tutorial. You should know how to make a mask in RAW.